Okay, let's continue part 3 of matter, and then we're in the concept of ions. We introduced the cation by losing electron from neutral atom, or the anion by gaining electron to the neutral atoms. So they are positive charge cation and negative charge anions, right? Now for this kind of process, we had an example for the electron transfer hand to hand. That's we call electron transfer during a formation of an ionic compound or ionic bondings, right? We're not getting there yet. But before we get into that, we try to extend this concept by losing electron or gaining electron in another deeper concept in chemistry called reduction and oxidation process. We try to get into this, and then so you have an introduction of that. Then later on you run into this kind of situation, you will be not too strange to that concept. Alright, so let's get into the concept of reduction and oxidation process, which is the extension of the electron transfer process. All right. So when we talk about cation, right, and then lose the electron, and then the anion by gaining electron. All right. Electrons negatively charged from neutral compound or neutral atoms by losing electron, right, getting positive charge cation, and then losing electron we call being oxidized, and the gain electron we call being reduced. Now let's use these two terms, very strange, unfamiliar terms, that we're going to explain. All right. The first term, reduction. Reduction is defined as by gaining electrons, the charge of the ion, right, or atom, right, become more negative. More negative. Alright, more negative. And on the number line, concept called number line. Now we learned the number line in algebra, the very early in your schooling in the middle school when you introduce pre-algebra number line, on the number line. Right? So getting more negative is what? Then this means the number, the value, right, towards the left. The left of what? The left of number 9, right? Alright, now let's leave a little space, so I'll give you an example. Now the second concept is oxidation. Oxidation is defined as by losing electrons. Let's put a apostrophe S here, so not only one electron we deal with, we may deal with more than one electrons. Right? Then the charge of the ion or atom, which is neutral, right? And it becomes more more positive, right? On number 9. The value move towards the right hand side. Right hand side. Under number 9. Now here we talk about number 9, and we are going to use the number 9 to show you after we do this. We put here. For instance, alright, so for example right here. Example for the problem we solved, right? Who gains the electron? Right, the oxygen gains the electron. In the example previous, right? Previous example, right? The oxygen atoms gain 6 electron, right? Where the electron come from? From our aluminum, right? This, right? And 3 oxygen atoms. Let's put here 3 oxygen atoms. Instead of D, we're gonna change to THREE. How's that? 3 electron atoms gain 6 electron, and each gains 2 electron. So what happened to oxygen, right, atom? Is 0 charged. The neutral becomes oxygen what? Anion. 2 minus charged anion, right? Anion. All right. And then here for aluminum. And also the previous example, right? And the 2 aluminum atoms, right, lose a total of 6 electrons, right? Each, right, loses, right, 3 electrons, correct? 6 divided by 2, right? 3 electrons. And then what happens is, in this case, the aluminum, each aluminum from 0 charge, right, atom, it becomes aluminum 3 plus charge cation. Correct? Now, let's see if we are able to represent this kind of process on the number line, because we use the number line, we mentioned the number line, right? On the number line, right here. On the number line, right? On the number line. So you remember number line. Now, let me tell you something. Number line is a tool for us to count integer numbers at the beginning of learning algebra or arithmetic, right? But the number line applies to science, especially in chemistry, in the general chemistry part, several places, several times. So number line is quite important. I don't think anybody ever really emphasized this effort from number line in helping student learning chemistry, but I think I need to point out because I find it very helpful, very useful, right? So let's do this. See if we can understand. For the aluminum, for the oxygen. So from the number line, what's the number line look like? A positive, right? Infinity, and here is negative infinity, right? In the middle is going to be 0, representing what? Representing neutral, right? Neutral. Right? And 1, 2, 3. That's probably good enough. Alright? So for the oxygen, starts 0, it gains 2 electrons. Now, electron is -1 charge each. So here's -3, here -2, and then it's 1, right? And +1, +2, +3. That's number line. Now the electron is negative charge. from 0, the gain 2 electrons. So for the oxygen, right? For the oxygen atom, right? Oxygen atom is right here, 0, right? But gain 1 more electron, add 1 more negative value, gain 2. So now here is -2. What is this? This oxygen 2 minus anion. So gain 2 electron, move towards this way, right? Is it this way? So you have a tendency towards the left. Now let me ask you something. Gaining electron, right? For oxygen case right here, right? The value of the charge or the oxidation state, whichever you call, in this case, let's just forget about distinguish, very feeble distinguish difference. The value goes from 0 to negative value. Is that increase or decrease? That's called decrease, correct? And in English, the decreased can also be called as a verb. The decrease can also be called as what? Reduced. Is that right? The noun form of reduce, the verb noun form of the reduce is called the reduction. Now that's why you gain electron, right? Let me put it here. Gaining electron is called the reduction. That's where the term reduction comes from. Alright? Remember, for life. That's what I found out. I did not live 200, 300 years ago, that time, but I figured out the reduction. Well, why we don't use any other term but gaining electron? We say gaining electron, right? Process. Why we reduction means the value of the charge of the particle, in this case atom or ion can be, and then the gaining more electron, the value becomes more negative on the number line, the value. Right? Numerical value decrease. A decrease means reduced. That's where reduction comes from. Alright? I think it's called in English, but synonymous. Right? So that's where it comes from. So it's called the left. Going to the left, it's called the reduced. Same as what? Decreased. Now that's where reduction, this term reduction comes from. So this is called reduction. So the noun is called reduction. Now remember for life. This is in chemistry a very important term. Alright, very important term. Now on the other side, this is oxygen. Right? This is oxygen. That's for oxygen, right? Oxygen. On this side say aluminum. The aluminum is we're losing electron. I say let's go to the right. Aluminum is losing electron. The number line getting towards the left is gaining and towards the right is losing. So let's draw the number line. Positive infinity, negative infinity, and an integer number right here, 0 right here, it's neutral. So if you have aluminum metal, right? All the utensil made of aluminum metal, very lightweight, the density was 2.7 gram per cubic centimeter, and then it's very durable. So we use it to make a lot of machinery, a lot of material, especially the cooking utensils made by aluminum. All those woks and then the pots. It's very lightweight. So aluminum is metal. And matter is neutral, doesn't have a charge, right? Neutral. But then you what? Lose electron. You lose electron, become positive charge cation. The lose electron, the value goes higher. So you start from aluminum atom. Here's a neutral here. Oh, sorry. Neutral, right? Neutral here. This is 0. And then it lose electron. Lose means subtract. Subtract the negative thing, we already discussed that. And it becomes more positive. How many electrons each? Lose 3 electrons each. So 1, 2, 3. So positive 3 right here, right? Positive 3, positive 2 right here, positive 1 right here. And negative 1, negative 2, negative 3. Now we never reach here because the charge or the oxidation state for that aluminum atom in that compound, before forming the compound, is a 0 charge in metal. Oxygen is 0 charge in the diatomic molecule in the air, right? At regular temperature in the atmosphere. So we're not easy to find very many atomic oxygen atom in the air because they are not as stable as that atomic molecule. We're going to get in there immediately, pretty soon, all right? So then you lose the electron, become positive charge. So what happened? So you go into here, all right? And going to here, what? Here is going to be the aluminum 3 plus charged cation, right? Cation. Now where the electron goes? Now what is this process called? Why is this process called the reduction? This process is called oxidation. Oxidation. Seems like something to do with oxygen, right? Oh yes, it is. Who needs electron? Where the electron goes? In this particular case, in many other cases, the oxide formed by what? By the oxygen taking or stealing the electron from another element to make it itself -2 charged anion to be more stable, because oxygen atom gain 2 more electrons will be exactly same number of 10 electrons, just like a noble gas neon, which is inert chemically. So that's why it's more stable. The oxygen is constantly in the thirst, in the very hungry state, want to eat more electron. Put this way. So it takes electron. So this process, by losing electron to oxygen, the oxygen is the entity to blame. The oxygen took the electron from aluminum. So that process we call oxidation. It's what we oxidate. Oxidation, it means the oxygen in this case, oxygen oxidize the aluminum and make aluminum lose its electron and gain by the oxygen, and then the aluminum being oxidized. So that is called, to the right hand side, right? In the number line, it's called oxidized. Aluminum oxidized by oxygen, and the process is called oxidation process. Now here is kind of reduction process. Now we explained fully, clearly, and completely. All right. So if you have any question, review this, and we are able to recall and review it more detailed and understanding of this. Now, that's the oxidation reduction. Now let's say if we are able to have some kind of example to explain that, right? You remember, I'm going to erase the top, right? And then let's see some example. Now that is kind of important, right? Let's, at this moment, since we're going to reach that point anyway, let me throw a big example related to the reaction. We haven't talked about reaction so far yet, but one reaction, right? The reaction we last section we talked about chemistry. If we want to learn solid chemistry, the chemistry equals what? Chem is tri. Remember that? CHEM is a liquid, and the IS is a gas, and the tri is aqueous. That's a whole 9 yards of chemical reaction. Chemistry equal chem is tri. Remember that, all right? So now let's throw in some kind of a reaction we deal with every day in your routine life. How about cooking? Cooking some Chinese food, right? I'm Chinese, okay? And Chinese food, and you have to cook on a stove. Normally we don't like electric stove. We like what? Gas stove. And have a gas burner, a big one. So the gas gives you high heat, right? And then stir fry all these tender meat, everything so tasty. But burning natural gas is the reaction we call combustion reaction. So what is natural gas? Methane. It's organic compound, right? CH4, methane. You probably don't know that compound formula, but I'll throw it in because I prefer throwing something you're not familiar with, but you get exposed because you did not get exposed when you were young. Now you have to put all these things all together in one shot, get everything done. So throw in and you get exposed, and in the future, near future, when you run into this compound formula, you're not going to be so surprised. Oh, I know that, right? The methane is a natural gas. Burning air. What is the components of air sustained burning, the combustion? The oxygen, not nitrogen. You know, the composition of air in the atmosphere is 78% of by volume is nitrogen gas, 21% is the oxygen gas. So we burn that 21%, which is 1/5 of the volume of the atmosphere. That's oxygen sustained burning. So in that case, we are trying to find the oxidation state for each atom, for different aromatic compounds, and what they have before the reaction, what they have after reaction. Is there any way we are able to figure out why they change the charge or change the oxidation state during the reaction? Because there's an electron being changing hand, transfer between two reactants, and that is called reduction and oxidation reaction, simplified as an REDOX. All right. So let's give an example. See if we are able to work this out. Right. Example: combustion reaction. By burning natural gas, methane, or in English called methane, right? CH4. Now the physical state of gas. I am a chemist, very, very picky on correct written physical state in chemical reactions. Everything else, that one was always being ignored, but I'm not, right? In the air with 21% by volume of oxygen. Let's put here oxygen, all right, in the air, which is O2G. Now that's physical state of gas. They're both gas. O2, diatomic molecule for oxygen, right? To form two very typical products. What are those? The carbon dioxide. You say dioxide, dioxide. CO2, also gas, and all right, and water vapor. Now, water vapor. Why is not the water liquid? Because now that's where the physical state play a very, very important role for the understanding of a chemical process. Because you're burning, right? You're burning natural gas and in the air with oxygen. You produce carbon dioxide as gas, but do you have the water dripping before a condensation? No, you have a water vapor because temperature is higher. Temperature is much, much higher than 100 degrees Celsius in order for water to be condensed into liquid. So it is immediately after reaction, the water is not in liquid state, it is in gas state. So that's gas, right? So the reaction is such, all right? The CH4 gas react, you say plus or mix them. In this case, it's not mixed. It's oxygen in the air, right? Of course, you have a one-way reaction. There's no way to come back. It's irreversible because it doesn't come back naturally or spontaneously by itself. And if a triangle down here means you heat up, right? You heat up. The heating, it does not, the symbol says heating, it does not mean you have to heat a certain temperature degree, but at least go beyond the flash point of this fuel, which is called natural gas, so it will burn itself, ignite itself, go beyond temperature we call flash point. The material will burn by itself, right? And then you have CO2 gas and water gas, all right? Now, this chemical reaction, right, it will generate some heat, some kind of heat right here. I don't know the value, but we can check that, right? But that's the whole process. One way, right, one way. Now, do we have to balance the reaction? Yes, we do, but let's see if we already learned a little bit. We haven't reached that point. We'll send you material, the handout, all right? Pretty soon about my own writing, stoichiometry, balancing equations, the whole nine yards. You will receive from email. Now first we try to, I haven't got into the tips how to fast, correctly balance equations of chemical process, but let's see, we normally go by metal first. Do we have a metal element? No, we don't have. Carbon is semi-metal, it's not non-metal, okay? Let me get a correction here. Hydrogen is on top of alkali metal, but it's in the normal temperature it's like a gas. It's not considered metal, but you can't say that's metal. But other than the hydrogen, we don't have metal. So we bury hydrogen, even is not normally considered as metal, but hydrogen, it is metal. When the temperature drops down to 269 degrees below 0 Celsius, the hydrogen becomes liquid, and then probably 1 or 2 degrees down, very close to absolute zero, Kelvin, then the hydrogen becomes metallic. You cannot make a noise just like metal, but nobody can live down that low temperature, right? So we balance hydrogen first. How many hydrogen atoms? 4 of them, right? That's 4, right? And then here we got 2. So on the left you got 4 atoms of hydrogen. You have to balance according to the law of conservation of mass. So you got to double this water, right? You got 4. Now the second is balance non-metal after metal or hydrogen, and the carbon one here, they balanced. Then count number of oxygen. Oxygen here is what? 2 oxygen and 2 oxygen, 4 oxygen. That's 2 in carbon dioxide and 2 in 2 water molecules, 4. Here's a diatomic diatomic oxygen molecule, and got 2 oxygen atom in there. But the total on the right hand side of the common product is 4. That's not enough, so you have to double this. So it is balanced now. So the mole ratio is 1 mole of methane gas require 2 mole of oxygen gas to be able to react completely from each other to produce 1 mole of carbon dioxide and 2 mole of water vapor. But that's the story, all right? Now, check it out, all right? Oxygen, diatomic molecule, is neutral. And inside the oxygen diatomic molecule, you have 2 oxygen atoms. They are identical, correct? They both belong to oxygen element. And they try to form bonding, which is double bond in this case. We are not getting there yet. The double bond, and then the electron forming bonding, each oxygen atom contribute 2 electrons to form 2 bonds, the double bond, and 2 electrons form 1 single bond, and 4 electrons form 1 double bond. And those electrons in between the 2 nuclei of 2 atoms of oxygen will be shared equally between the 2 nuclei, because none of the oxygen atoms is strong than the other to pull the electron towards itself, make itself more negative and make the other oxygen more positive. So they share. So in that case, we are able to say that's a 100% covalent bond, and then the charge to the outside for diatomic molecule, most of diatomic molecule, chlorine gas, hydrogen gas, they all have exactly neutral status as a 0 to the outside charge, 0. So 0. But here, look at oxygen. Look at oxygen. That's a compound because you have 2 different kind of elements, right? Carbon, recall carbon position in periodic table is 4A. Either +4 or -4. What is the possibility here? The oxygen, let's check oxygen. The oxygen, I said, 99% of the case, oxygen shows 2 minus charge. Okay, and time's up. I think I'm going to continue from this on, and we try to figure out the charge of each elements in the compound related